What we're basically doing in this second section now is, I guess, how we can expand trig out, and then there's also a bit about how we can combine it back in again as well. So we're going to start with this, and there it is. It's simply the unit circle, radius 1, unit circle. There's point P, and I could work out the coordinates of P using that little right angle triangle in there. If I call that angle in there beta, then simple trig to work out the x and the y value. X would end up being the cosine of beta, y would actually be the sine of beta. They're actually what we call the parametric coordinates of a circle. We'll see more about parametrics later in the term. So okay, it's got the coordinates cosine b, beta, sine beta. Now it does not matter where I put P on the circle, it'll always be the cosine of the angle, but again it has to go back to the positive x-axis, the angle, and the sine. So if I put one over there, let's call it Q, and I'll say that angle that it makes with the positive is alpha, then that would be cosine alpha and sine alpha. And you might be thinking, well, hang on a sec, over on the left hand side surely the x value is negative. Well, it is, because it's cosine of alpha, and if you have a look at my angle alpha, it's obtuse, and the cosine of an obtuse angle would be negative. So we don't go negative cos alpha because it's over on the left hand side. The angle will take care of the positive and negative. So it's always cosine of the angle, sine of the angle. So what I'm interested in is the distance between these 2 points, which I can calculate 2 ways. I could use trig and my cosine rule. Imagine the triangle OPQ there. So the angle that I'm working with would be alpha minus beta, whatever that is. And so we'd have 1 squared plus 1 squared minus 2 times 1 times 1 times cosine of alpha minus beta. Tidying that up, I get PQ squared is 2 minus 2 cos alpha minus beta. That's where I'm going to leave that one. The other way I could do it is using coordinate geometry and the distance formula. So PQ squared, I've just got rid of the square root sign by making it squared. The difference in the x value is squared plus the difference in the y value is squared. Expand that out, and you can see we've got a few cos squareds plus sine squareds there, which will become 1. And I end up with 2 minus 2 cos alpha cos beta minus 2 sine alpha sine beta. Now I actually lied to you. I'm not really interested in the distance between the two. What I'm really interested in is the value of PQ squared. Because if they're both equal to PQ squared, then they must be the same thing. So I can conclude from that 2 minus 2 cosine alpha minus beta is 2 minus 2 cos alpha cos beta minus 2 sine alpha sine beta. So if I divide everything by 2 and then cancel the 2's, we come up with the first of our formulas. Cosine of alpha minus beta, cos alpha cos beta plus sine alpha sine beta. You see, you can't expand out like parentheses. It's not, cos is not a factor of alpha and beta that we've pulled out. So you can't expand it out and go cos alpha minus cos beta, which I think is a mistake people see when they first see something like this. We have to use this formula if we want to expand out that sort of parentheses with cosine out the front. That's the first of the formulas. What I'm now going to do is I'm going to replace beta with negative beta. And if I do that, cos alpha minus beta becomes cos alpha plus beta. And I have cos alpha cos negative beta, sine alpha sine negative beta. But now I'm going to play around with odd and even functions. Because you'll remember cosine is an even function. So therefore cosine of negative beta is the same as cosine of beta. Sine is an odd function. So therefore sine of negative beta would be the negative of sine beta. So I could now rewrite that formula to be cos alpha plus beta is cos alpha cos beta minus sine alpha sine beta. And there's a lovely little pattern there. How I remember it, now I've just written it like this, combining the plus or minus. And you'll see over on the right hand side I put minus plus. So in other words, whenever it's plus on the left hand side, it's minus on the right hand side, and so on. Because the way I think about it is like this. It always goes cos, cos, sine, sine. See, cos, cos, sine, sine. But then, if it's not the sine, which in this case it's not, right, because it's cosine, then it's not the sine. So it's not plus, it's minus. See? So cos, sine. If it's not the sine, it's not the sine. Okay? Let's now replace alpha. We're going back to the original one. We'll replace alpha with 90 minus alpha. So I get cos of 90 minus alpha minus beta, cos of 90 minus alpha, cos beta, sine of 90 minus alpha, sine beta. Now I'm going to play around with complementary ratios. Okay, because the cosine of 90 minus an angle is the sine of that angle. So on the left-hand side, that will become, because it's actually 90 minus all of alpha plus beta, so it becomes sine of alpha plus beta. And the cos of 90 minus alpha becomes the sine of alpha, and the sine of 90 minus alpha, there it is, cos of alpha. All right, so there's another one if I want to expand out sine. Let's replace beta with negative beta in that one and see what happens. So same sort of idea, left-hand side becomes alpha minus beta, but now playing with the odd and even functions, the cos of negative beta becomes cos beta, the sine of negative beta becomes minus sine beta, and again we have a pattern. But you'll notice this time, plus minus on the left-hand side, it's also plus minus on the right-hand side. So how I remember this one, sine cos cos sine, if it's the sine, and it is in this case, then it is the sine. So we don't change it. It stays as plus. You think, oh my goodness, how do you remember that? But you see, what you've got to remember is cos always goes with cos. So you're always saying cos cos. So as soon as you say cos, you say cos. And when you start doing it, you start with whatever you're finding. So when I was finding cosine of something, I start with cos. Cos, oh, I just said cos, so I'll say cos again. Cos, cos, which leaves sine, sine. If it's not the sine, it's not the sine. But when I start with sine, I go sine. Oh, now I'll change to cos. Oh, I just said cos, so I'll say cos again. And there's one to go, so sine. So we go sine, cos, cos, sine. If it's the sine, it's the sine. So there's a little way of remembering the pattern, how I do it. You're going to be surprised when you're doing these questions. You'll find yourself now going, cos, cos, sine, sine. If it's not the sine, it's not the sine. And of course, when you're doing it with your friends in the library or something, they'll just be looking at you going, what on earth are you talking about? Okay. Well, let's work out tan then. Tan of alpha plus beta. Well, we know tan is sine on cos. And we've just worked out sine, cos, cos, sine. If it's a sine, it's a sine. And on the bottom, cos is cos, cos, sine, sine. If it's not the sine, it's not the sine. Now, that looks like a bit of a mouthful to remember, so I'm going to make it even more complicated. Okay? I'm going to divide everything by cos alpha, cos beta. Okay? And again, you're looking at that thinking, are you insane? And probably the answer is yes, but anyway. But you'll notice there's a whole heap of cancelling there. In that first fraction, cos cancels with cos, leaving me with sine on cos, which is tan. The second one there, cos alpha is cancelling with the cos alpha, leaving you with sine on cos, tan. Then we go to the bottom of the fraction, cos cos on cos cos, well that's just one. And then you have sine cos, well that's tan tan. There's our formula. Tan alpha plus tan beta and 1 minus tan alpha tan beta. Well, let's replace beta with minus beta on this one and see what happens. Now, tan, odd or even function? Odd. So tan of minus beta is the minus of tan beta. Okay, so substitute that in, and there we get tan alpha minus beta, tan alpha minus. Well, if I was to combine those two together, let's see what happens. Well, alpha plus beta, the top of the fraction the sign doesn't change, but the bottom of the fraction the sign does change. So I just simply remember the plus one, and what we've got is tan plus tan on 1 minus tan tan. So if you ask me the tan, oh yes, tan plus tan on 1 minus tan tan. And then of course if it's the minus 1, I just change the signs round. So in summary, there we go, the sine. Sine, cos, sine. If it's the sine, it's the sine. Cos, sine, sine. If it's not the sine, it's not the sine. And tan plus tan on 1 minus tan tan. Let's do some examples. So now if we have to expand out something like this. Yes, it's not like algebra. As I say, you can't just go cos 2 alpha minus cos 3 beta. Well, you can do it, but you'd be wrong, of course. So that's not much fun doing it that way. We want to go cos, sine. If it's not the sine, it's not the sine. So there's the expansion of cos 2 alpha minus 3 beta. That's how we expand parentheses when it comes to trig. Simplify this expression, and you're thinking, hang on, I don't have an exact value for tan 20. I don't have one for tan 10. But if you look at it, look at the pattern. And what we have is, oh, hang on, tan plus tan on 1 minus tan tan. That's just tan 20 plus 10, which is tan 30. And we do know that one. That's 1 on root 3. Now, if I want to work out sine 15, what we got to do is come up with a combination of exact values that we know and get the answer of 15. Now, there's different ways we could do it. I could go 60 minus 45. I could go 45 minus 30. There's all different ways. Which way did I go? I went 45 minus 30. So now I'll use my expansion. Sine, cos, sine. If it's the sine, it's the sine. And I can now substitute in all those exact values. We have a common denominator there of 2 root 2. And there it is, root 3 minus 1 on 2 root 2. No, I don't bother rationalising the denominator on that. I just leave it like that. Now, they're telling me sine alpha is 2/3, cosine of beta is 1/4. Find the sine of alpha plus beta. I suppose temptation is to go to the calculator, work out what alpha is, then work out what beta is, add them together and go the sine of that. Problem is, you're dealing with approximations. Because if you go to your calculator for alpha, it's going to approximate. Same with beta, it'll approximate. How do we do it with exact ones? Well, I'm just going to draw up a triangle for each of those. Alpha and beta are not in the same triangle, okay? So the first triangle I've drawn is for alpha. They've told me sine was 2/3, so the other side's the square root of 5. Then I'll draw one for beta, and the other side root 15. I want to find sine alpha plus beta. Sine, cos, sine. If it's a sine, it's a sine. And then I'll just read off my triangles and substitute in. Common denominator in this case is 12. So I've got 2 plus 5 root 3 over 12. And then I get an exact value. Whereas if I had gone to my calculator, I would have ended up with just a decimal approximation. Okay. So that's how we expand out in trig.